Recently, I was commissioned by VIVERSE to create a 3D virtual world complete with destructible environments. I'm excited that I finally get to share this project with you today, but more importantly, I'm going to show you how you can add destructive capabilities to your own VIVERSE worlds. Finally, I'll show you how you can publish from PlayCanvas directly to VIVERSE with just the click of a button. And from there, you can play on desktop, mobile, and especially VR. Now, if you're not familiar, VIVERSE is a platform for building, sharing, and playing immersive 3D worlds. The easiest way to create these virtual worlds is by using PlayCanvas, which is a browser-based game engine similar to Unity and Godot. Now, before we dive into creating our own game with destructible elements, let's first take a look at this first-person shooter demo I wrote and see how it works. So this is the first-person shooter demo in action. Now I'm playing on my desktop because it'd be a bit hard to record this with my headset on. But the idea here, it's pretty simple. You just run around the map and you try and locate these targets. Now the closer you shoot to the middle of the target, the more points you get. But the other fun aspect of this is all of the props in here are destructible. So I can shoot these barrels, they'll break apart. I can shoot these pieces. They all have physics enabled and collision detection. And it just makes for a much more fun and interactive game experience. Now what you're looking at here is the PlayCanvas editor, and this is where you're going to be building your 3D world. Now this video isn't going to be a tutorial about PlayCanvas, but luckily there's a lot of really great documentation, examples, and tutorials out there. So for example, I'm looking at the examples page for PlayCanvas right now, and there's at least over 100 different examples here that you can look at. And I'll post the links to these in the description so you can check out these demos and examples for yourself. And another great one here is the tutorials page. So if you just go to developer.playcanvas.com/tutorials, you can see all of these different tutorials. Let's take a quick look at one here, collisions and triggers. So most of these do have a write-up underneath them. Some just have a link to a project that you can check out with the source code. But lots of different things you can look at to get ideas for your games or learn how to do certain things in PlayCanvas. Now later on, I'll show you exactly the steps you need to take in order to add all the destruction library code in your PlayCanvas project. But I thought we'd take kind of a 1,000-foot view of the destruction library and just kind of see how we would add it to a component and how we configure it. In my scripts folder here, I have this fracture script, which contains a lot of the logic, and you can see the fracture library code. So that is a library I actually wrote myself initially for Unity back in the day, and I've since ported it over to Three.js and PlayCanvas. But that's located in this folder here, and that's just exported as a JavaScript module. I'll show you how to load these later, don't worry about that right now. But let's take a quick look at this box here, which has the destruction added to it. So of course we have our render component, so we can render the box. It has our cube asset here, our little crate. Then we have a box collision component added here. And of course we have a rigid body component to enable the physics. So all of these sort of interactive dynamic props within the scene have this render component as well as the collision and rigid body components for the physics. Now let's take a look at these scripts here. And I really only have one script, and that is the fracture script that I added. So let's take a quick look at all the different properties and attributes associated with this. So the first attribute on our script is this Boolean fractured, and that just indicates whether or not this particular instance has already been fractured or not. So we know to ignore it if it has been fractured. The second attribute is the fragment count. So we can set this from anywhere from 2 all the way up to 20. Now, of course, if you pick a higher fragment count, that's going to have a higher performance impact. So I picked 10 because that's kind of a good middle of the road. I got pretty good performance on my headset with that. But of course, just keep in mind, if you're fracturing a really complex model, that's going to take more computation time. So it's a balance of model complexity, the hardware you're working on, and how many fragments you want that to break into. Now the next property here, inner material. So if we think about slicing this box in half, when we open that up, we have these two new faces that we're creating on the inside of the box. Now we need to apply some texture to that new geometry, and that's what inner material is used for. So you can imagine if you are breaking apart a statue or something, you might want to have like a rough texture on those fractured faces. So this is a useful thing where you can assign maybe a different material than the material you're using on the outside of that. And of course, we have some scaling and offset for that intermaterial texture. So if you need to tweak that a little bit, you want the grain pattern to maybe be smaller or larger, you can use texture scale for that. And then fracture planes allows us to control along which axes the object will fracture. So if you want to fracture from any which way, you just check all of these. Now, if you want to maybe slice it into planes or slice it into little sticks, then maybe you can uncheck X or, kind of get the effect that you're going for. So our next attribute here, the tag filter, this controls what triggers the fracture. So I only want the box to fracture if I shoot it with a projectile. So this needs to be set to something. Otherwise, the minute it were to touch any other object in the scene, then the box is just going to crumble. So we need some sort of filter here to prevent this from fracturing unless some condition is met that it collides with our desired object. And finally, we always want to be able to play some cool sounds when our object breaks apart. So I've actually created this as an array, because if you're just breaking box after box, it's playing the same sound over again. It gets a little annoying. So I've made this an array so it randomly picks one of these sounds when a box breaks apart. Now, if we go look at maybe this plank instead, it's really just doing the same exact thing. I have it configured about the same. It's using the same sounds, using the same fracture settings. If you go look at this barrel, I'm using a different inner material here, but really all of these other settings are the same as well. Now let's dive a little deeper and look at the fracture script itself and get an idea of how the logic is implemented. You don't need to understand every little detail of this, but it's good to know at a high level how it works, because there's probably some tweaking that you're going to want to do for your game or application. So of course we have our attributes all defined here. Now this fracture mode attribute here is actually pretty important, and I'm going to show you why. So there's two different options here. We can either do non-convex or we can do convex. Now, what is the difference between convex versus non-convex? So when we're talking about convexity, we're talking about the angles of the geometry of the 3D model that we're about to fracture. So of course, this illustration is in 2D, but the same applies to 3D. So on the left, we have a concave object, and we can see that it has an interior angle that is less than 180 degrees. Where our convex objects, all the angles between the surfaces here are 180 degrees or greater. So I'm kind of measuring from, this side, if I do an angle all the way around to this side here. So the calculations required for fracturing a non-convex or concave object are quite a bit more complex than the convex case. So that's handled differently in the destruction library. So if all the objects that you're trying to fracture are convex models, and it's good to try and get them to be convex if possible. That's going to save you quite a bit of performance versus if you're running the destruction code in non-convex mode. But just know that both cases are supported, so pick the one that's appropriate for your game. So scrolling past the other attributes here. So one thing that we do right away in this fracture code is we listen for any collisions. So we listen to the collision start event here. And then we have this callback function here when that event is triggered. So first thing, we check to see if the object that we're colliding with has the appropriate tag in our filter. So if it doesn't have the right tag, then we just abort right away. And then if the object has not been fractured yet, then we're going to destroy the projectile. We're going to play our fracture sound, our smash sound, and then we're going to call the fracture code here. Now, anything that you're going to be modifying for your game is likely going to be above this point. Basically, in this onCollision start function, there likely won't be much of a need for you to modify the fracture code directly, but just in case, let's do a quick walkthrough of what's going on. So first thing is we get the asset on our entity. So that's the thing that we're going to break apart. And then we set up our fracture options, which are just linking to those attributes we've defined. And then we're going and getting all of the geometry associated with our asset, our mesh. And then we're calling our library function here, fracturing the raw data. So we're passing in the position, normals, UVs, and the indices, in addition to the fracture options. And then that's going to return a bunch of fragments. So we're actually disabling the entity that we're fracturing. We're creating a bunch of new entities that are all the individual fragments. So we take those fragments and then we pass them into this function, create fragment entities. Then we're going to just create all of those objects and add them to our scene. So I'm not going to run through all this code. It gets quite complex. But basically, it's just going through and creating all those entities, adding the collision, the rigid body components. And another thing of note here is if we were to just let all these fragments pile up in the scene, our performance is going to drop pretty quickly because the physics engine is just going to be running all these computations on all these objects. So what I've done to avoid that is I've added an additional script here called fade out. So let's take a quick look at that one because I think we've really looked at everything here that we need to. So we go to fade out. So basically what this does is we just have a certain time limit, about 5 seconds here. And this is going to be attached to all of the fragment objects that we're creating, all those entities. And then after that certain amount of time has elapsed, we're going to slowly fade the object out. We're going to decrease its opacity. And then once the entity is fully transparent, then we remove it from the scene. So that's a bit more graceful way of removing an object rather than just removing it instantly and having sort of that object disappearing. It's kind of abruptly like that. We do the slow fade out to make it look a bit nicer. So that was the 1,000-foot view of our destruction library. Now let's go down to ground level and build out our own game that uses this destruction library. Now let's take a quick look at what we're going to be building here. So I thought we'd make a simple platformer where we have these platforms leading up to this ledge we need to get to here. And these platforms have the destruction code attached to them. So I've modified it where the player jumps on it, and 2 seconds after they jump on it, the platform will fall apart. So there's kind of a timed aspect to it. You're trying to hurry and get up there before the platforms fall out from under you. So let's try this out, see if we can get up there. Get lined up here. And start jumping up here. Oh, all right, just made it. And you can see the platforms crumbling and fading out. But we did make it up here, and now we can move on to the next part of the level. So this is just an example of something you can do with this library. So let's see how we would go about building this in PlayCanvas. Now, first thing, you're going to need to go to playcanvas.com and create an account there. And when you do, you should see a screen that looks somewhat like this. So I have my target shooter example here, and this is the example I just showed you. Now it's called roll a ball because I am using a template. I thought that would save us some time rather than building everything from scratch. We can use a pre-existing template. So go in the upper right here, click on new, and then I'm using the roll a ball template. So this has some physics and all the platforms and materials built into it. So let's go ahead and create that. So it'll take a few seconds to set up that project. I made a new fork of that and created it here. So let's go ahead and click on the editor. So this is what it looks like. Let's launch this right away. So you can see this is just kind of a rolling ball game. So we'll just be modifying this a little bit in order to kind of make it work for our purposes here. So let's just start by removing the components that we won't need. So really all I need is one of the platforms. I can get rid of everything else here. So I'm going to add the destruction code to one platform, and I'll duplicate that. Now, when we publish our world to VIVERSE and we open it up, our avatar is already going to be pulled into that world, so we don't need to do anything there. But we will need to add in a floor that the player can stand on, so we'll do that in a bit. But the first thing that we need to do is we need to set up the VIVERSE integration. So on its own, PlayCanvas is not hooked up to VIVERSE. There's a browser extension that you need to install. So luckily that setup is pretty easy. There's some good documentation for that. And I pulled it up here. Of course, I'll provide a link for this in the description. This is on the VIVERSE documentation site. This is the PlayCanvas extension setup. So of course, the first part is setting up your PlayCanvas account, which we've already done. We've created a new project. And now we need to go and download the PlayCanvas extension. This is a Chrome extension. So if you're using a different browser, I don't think that's going to work. You're going to need to use Chrome here. But go ahead and follow the instructions for downloading this and getting it added to Chrome. So I've already added it. You can see it right here, VIVERSE PlayCanvas extension. Now if I click on this, we see it says refresh the page to activate the extension. So if I go back to my project and I were to refresh this page, you should now see a button called Publish/Download, which I think already exists, but if you click on this, you'll now see this box here with this option to publish to VIVERSE. So we're not going to publish right now. We got a little more setup we need to do, but that is really all you need to do to get PlayCanvas hooked up to VIVERSE. It's pretty simple. And then anytime you want to go and run your code and test it out, you push this Publish to VIVERSE button, and it'll pull up a preview environment. So let's start by adding a floor that our player can stand on, and then we'll add that kind of second ledge that we want our player to get to. So I'm going to go and add a new entity, 3D plane. I'm just going to scale this out in each direction. So this will be in the X and Z axes. So that'll be our floor. So we need to add a collision component. So one bug I think currently with PlayCanvas is if you start changing any of these collider properties, the collider disappears. So that can be fixed by just refreshing the screen, and then it should work from there. So I'm going to set this to 5 and that to 5. And then I'm just going to offset the Y position here down to right about there. And it's better to use a thicker collider. You don't want to use a really thin collider because if things are moving really fast in the scene, it might pass right through it. All right, so we have our plane there, our floor. You can just go ahead and call that floor. Now I'm going to add a ledge. So that's going to be a box. And make this scale, let's see, it should be 5. Yeah, we'll just go with 5 here, that's fine. And then we want to scale it in the Y direction by 5, maybe by 3. And then we'll need to, let's make it a little bit wider too, so we have a place to stand. All right, now we need to add our collider. So there's our box there. Let's extend that out. Doesn't need to be perfect here, just close enough is good enough. But I think these are just going to be half of our scale factor. Now the other thing we need to do is make sure that we add, in addition to the collision component, we need to add a rigid body component. That's kind of the final piece needed for the physics interaction to work. So let's just leave it as static. That means it's not going to move, and keep the friction and the restitution. This kind of controls the bounciness of it. So add rigid body here as well. And let's just create some platforms that our player can jump on. So I'm just going to duplicate these a few times. So there we have our basic world set up. Now I think we're ready to go test this out in VIVERSE. Now one thing I forgot to mention here is that when you install the VIVERSE extension and you refresh, it's going to add this folder here in your project at VIVERSE. And this is going to just contain some JavaScript files in there that's going to help, when you start your project up in VIVERSE, it's going to load in the necessary SDKs, the Create SDK and the extensions. So if you're wondering where this came from, that was from that extension. All right, so let's go to Publish and download. We'll publish to VIVERSE. My only gripe here with this is that it does take some time to publish to VIVERSE. Every time you need to make a change to your code, you do got to wait around like 20 to 30 seconds before you can test it out. Not much different than, if you're using Unity and you got to wait for your scripts to compile. But it can add a little bit to the iteration cycle. Now, before we jump into preview, on that note of testing in VIVERSE, there's a launch button here, which you typically use when you're creating a PlayCanvas project. But if you're building a VIVERSE world in PlayCanvas, this is no longer going to work. And that's because these VIVERSE SDKs here, they really only work when you open them up in the context of VIVERSE. They don't work, in the context of launching directly within PlayCanvas. So don't want to use this button. If you're building a VIVERSE world, you want to go under Publish Download, make sure you publish, which we just did, and then hit the preview button. So you can see my URL here is create.viverse.com. So this is hosted on VIVERSE. And now it loaded my character in, and we have our world here. So it looks like I set everything up right. My player didn't fall through the floor. I should be able to jump on these platforms and get up here. All right. So that's all working. Now let's go ahead and add some destruction code in. Now the first thing that we're going to need is we'll need to install the THREE-PINATA library, which is the name of my destruction library that I wrote. So I initially wrote this for Three.js. PlayCanvas and VIVERSE do not use Three.js. So if you don't know, Three.js is a pretty popular 3D library for JavaScript. Luckily, it's all kind of the same stuff under the hood when you're dealing with, the geometry and breaking it apart. So I was able to port this over to be used in PlayCanvas quite easily. All you need to do on your side, if you're consuming this library, is you just need to get the code, and that's under the build folder here. And it's going to be the THREE-PINATA, I believe it's the .es version, the ES module. There's also one using UMD modules, but that doesn't work in PlayCanvas. So the easiest way to get this code is through JS Deliver. So that's a CDN that automatically publishes NPM packages so you can get the source code. So I'll provide the link for this in the description. So you can just come here and grab this code. So I'm just going to copy all of this. And then we'll go back into our game here, and I'm going to create a new folder. And I want this at the root level. And I'm going to rename this to @dgreenheck. And then within here, I'm going to create a new script. And we're going to call this three-pinata.core.mjs. Now the MJS extension means this is a JavaScript module. That's how PlayCanvas recognizes JavaScript modules. PlayCanvas is just starting to support ES6 modules, which is really great. Makes things a lot easier in terms of code portability and importing scripts and things like that. So that is how I have packaged the code to work in module form. So let's double click on this script here, and that'll open up the code editor. I'm just going to delete all of this, and I'm going to paste in all of this code that I copied here. Now that we've imported THREE-PINATA, we're ready to add our fracture script. So unfortunately, there isn't a great way of sharing scripts. There's no central repository for PlayCanvas scripts. So I'm just going to go to my Destructible target shooter project here, and I'm going to copy these scripts. So I'll provide the link for both of these projects so you can go and check them out yourself. I'm going to start with copying this one. And I think I can copy across projects here. Let's try that. Let's go to my scripts folder and paste. So it looks like that worked. And then we also need the fade out script. So I'll copy that one and paste that in. All right, so we have those two scripts. So it looks like they've parsed correctly. Everything's working there. So let's go and add the fracture component to one of our platforms here. So at the very top, I'm going to click Add Component, and then I'm going to click on Script. And then we'll go down here, and we'll add the fracture script. Now for the material here, for the inner material, I'm just going to set that to the platform material. That'll work just fine. And since our scene is pretty simple, we can get away with some more fragments. So we'll do like 16 fragments. And I want this to fracture in the X and the Z axes. You could really do all three of them. I wouldn't matter too much. Yeah, let's just use all three. Really, I was just thinking of having it kind of fracture along the surface here. But I think it'll work either way. All right. So for the tag filter, I'm just going to set that to nothing because our avatar is going to be colliding with that. And these are just floating up in the air, so nothing is going to be colliding with them to begin with. And we also need a sound here when it breaks. So I'm going to add a new folder. And I'm going to call that folder Sounds. And I'm just going to grab one of these sounds that I got from my project here. I did add a attribution file in here. So if you are curious where I got these sounds, I got them from freesound.org, and here's the license for that. So you can go and use these sounds, or you can go to freesound.org and find your own sounds. So I have my sound imported in here. So I can go back to my platform, scroll down. So we're gonna have just one sound, and let me pull this out here. So set the array size to 1, and then I'm gonna set this to that sound there. All right, I think we're good to go there. Now one tweak I'm gonna make to the code here is I had a line in the onCollisionStart event handler here. And if a fracture occurs, then it's going to destroy the other object that collided with the platform. Obviously, I don't want to destroy the player avatar, so we're just going to go ahead and delete that one line there and save that. Now we should be ready to test out this platform. So when I jump on the platform, I would expect it to break. So I'm going to go back to Publish. I'm going to republish this to VIVERSE and test it out. All right, I'm back in my VIVERSE world. Now if I test jumping on this platform, I expect it to break, and it does. So let's see if it fades out now. And it did not, so it just disappeared instantly, which is not what we want. So let's go fix that. I'm gonna go back to my editor, close this. So the way the fade out script works is it modulates the opacity of the material. So let's go find our platform material here. And if you scroll down and look at our material properties, let's find the opacity tab. So currently this object has no transparency whatsoever, which is why the fade out is not working. So set the blend type to alpha. And then another good thing to do is set the opacity dither to Bayer 8. That just helps kind of smooth things out a little bit. Gives kind of an interesting effect when things are fading out. So that should automatically save. Now we can try it republishing and testing again. Okay, so I'll jump on this platform one more time. It breaks. Let's see if these pieces fade out. And there we go. They fade out quite nicely. The shadows are left over a little bit, but not much we can do about that. So I'm going to go ahead and I'm just going to delete these other platforms and reduplicate that other platform with the fracture code on it. And then I think we're pretty close to being done here. The only other change we need to make is adding a delay so we have some time to jump from platform to platform. Because right now it's instant. So we'll go in the fracture code and we'll set a timeout to give us like 2 seconds or so to jump to the next platform. So I went and recreated these platforms. So now they all have the fracture code on them. And I think this is also using a template for the platform. So, you know, that probably would have been a better idea is just to apply the changes to the template. But, you know, a couple of ways to skin the cat. So let's go into our code editor, into our fracture script. And then in onCollisionStart, right after we determine that a fracture is going to occur, let's put a timeout in here. So we're going to set fracture to true so it won't trigger it multiple times. And then I'll do set timeout. We'll pass in a callback here. And let's use a timeout of 2000 milliseconds or 2 seconds. And then we'll save that. And then I'll go and publish this one more time, and that should be our final demo completed. All right, so let's test everything all put together now and see if we can get our platforms to crumble here. So I'm gonna jump up onto this one. Gotta hurry here. This is a little nerve-wracking. And there we go. See, all of our platforms are crumbling now. The fragments are fading out as expected. And there we have it, a platformer with destructible elements. Now the last step of this process when publishing to VIVERSE is publishing your world to VIVERSE worlds. So we're in the preview environment right now. So to publish this to a production environment, all we have to do is find the Create World button here in the upper right, click on that and give it a title. So I'll call this My Destructible Platformer. Hit create, and pretty much instantly that's going to create a link to your world here. So we could just click on go to world. This is going to open up VIVERSE worlds. And now your game is published and ready to share with anyone. So you can open this up in your VR headset. You can open this up on your phone and play it on any of those. Now you will have to, code up the controls to work in those different environments. This one, might need a little work with the jumping mechanic in VR. You have to figure out how that might work. But that's all part of the game development process. All right, so that's a wrap. I hope you found this tutorial useful and it gave you some cool ideas for some destructible mechanics that you can implement in your VIVERSE worlds. And I just want to give a special thanks and shout out to VIVERSE for sponsoring this project. It was a lot of fun to make, and I can't wait to see what people build with this destruction library. Until next time, thanks for watching. Take care, everyone.